Hello, homeschoolers. My name is Laurel. Welcome to the land of Kakiak. That's Bo. Bo, what are you doing? Okay, so today we are going to continue in our ocean anatomy lessons, and I just thought I would take you along on the activity portion from the activity book. And today we'll be talking about ocean currents. Okay, so I've got ocean anatomy activities for kids, fun hands-on learning. So my favorite part about this is actually the little section, the little reading section to begin with. You get a lot out of this section. So we already read ocean anatomy, the section talking about ocean currents, and did the notebooking pages. And so now we're just going to move on to this. So ocean currents. The crashing of waves at the beach is one way we experience the constant motion of the ocean. In this lesson, we will learn where and how the ocean moves, as well as the forces that create this motion. All right, so we read through there. And fun fact, it takes approximately 1,000 years for one drop of water to circle the globe on the global ocean conveyor belt. Is that interesting, William?
Yes.
It is. Okay, let's take a look at the activity. Okay, it looks like this.
Ooh, that's super good.
Okay, so you guys are going to help me with the prep work, okay? Materials. We need rocks and gravel. I think we've got some of those outside.
Yeah.
A 9 by 13 inch shallow metal pan. I have one of those. I'll get that. Room temperature water, ground black pepper, and a drinking straw. All right, we have all those materials. You guys be in charge of getting some rocks and gravel from the yard, okay?
Okay.
Ready, set, go. Okay, so here is your final arrangement of landforms. Okay, so it says, gather your materials. We've done that. Arrange the rocks and gravel into piles at the edges of the pan, leaving space in the middle. Okay, so it says to leave space in the middle. So see how their stuff is on the corners? So maybe move some of your rocks to the corners. There we go, leaving space in the middle. Step 3, fill the pan with water, leaving the top of some of your landforms out of the water. This creates a model of an ocean basin. Okay, so this is what the ocean basin looked like. They've got their landforms in the corners, and we've got a room temperature water in there. So now we're going to move on to shake a small amount of black pepper onto the surface of the water. Imagine that this is debris floating on the surface of the ocean. Okay, step 2. Without touching the surface, blow gently through the straw from one side of the pan. This represents wind blowing over an ocean basin. What happens to the pepper on the surface? Okay, go ahead, William. Blow gently. There you go. What's happening? Look at it. Do you see what it's doing? Perfect, William. Do it again. You're doing it perfect. See how it's moving in a circular pattern? Going one way to the right and the other one way to the left. Okay, so when you guys blew it, what happened to the pepper?
It got mixed up.
It got mixed up?
Yeah. And some fell to the bottom.
Oh, yeah.
Yeah.
The heavy stuff did, didn't it? Everett, what did you say? You said it was moving in what kind of shape?
Circles.
Yeah, it was like moving in circles. Okay, so now let's go to the next. Stop blowing through the straw. Okay, we did that. Begin blowing gently again through the straw in a different area over the pan. Okay, Everett, get your straw, not the same one that William's blowing into. Oh, look at that.
What? Ooh, that's cool.
What's happening to the pepper now? Very gently.
It's moving around and going back
Yeah,
and here.
it is.
Yes.
Good job. I see that circular. What did they call that circular pattern in our reading? Do you remember?
I don't remember that thing.
They called it it's right here, the Coriolis effect. I see. Oh, you guys, suddenly there was a new island. How is that going to affect the currents? I'm going to let them play an experiment with this to see if they notice some changes in currents when they're moving their land around or the wind. But I was just looking at the back of the book and I saw back here, it says videos, how do ocean currents work? There's a TED Ed. So I'm gonna go bring that up while they're doing that and see how long that one is. Bringing up this video on edted.com.
Currents are driven by a range of sources: the wind, the tides, changes in water density, and the rotation of the Earth.